one of my favorite lessons because it's not mathy. It's more logical. I love it. It's logical. So let's talk about it. Let's start with the difference between an observational study and an experiment. And the biggest thing with an observational study is the data's already been collected. And we just go in and look, and we're trying to infer something, but you cannot infer causation. We're just trying to like gather some kind of information. But for an experiment, we're actually controlling the data. So in that case, you may infer causation. So if on the AP exam, they give you a question where they say, data was collected from something that happened a while ago, then that's going to be an observational study. If they say we ran an experiment where we had a treatment and a control group, then that's an experiment and you can infer causation. I will post one or two of these videos. One or two of these was really good. One was kind of long. That one's long. That one was good, but I don't think yeah, this one's good. We'll look at it. We're not doing the packet. We're doing different stuff. So this was for my old class back when we had live classes. All right. So this is the from Khan Academy, and I have put his link in there. So he did a great job. It's like a 6-minute video, and he talks about the difference between a sample study, an observational study, and an experiment. And just in a nutshell, a sample study, you had some population and you grabbed a sample from that to find some kind of an estimate of a population parameter, like how many people have cholesterol over 200 in this particular group, and then you'll have some proportion, like 28% had cholesterol over 200. In an observational study, you're trying to equate two variables like blood pressure with how much time you spend on the computer. So in an observational study, you may gather 1,000 people and measure these two things about those 1,000 people. You want to see if you can find a correlation, but remember, for observational studies, no causation. For an experiment, you could say, let's take 100 people, break them into a control group and a treated group, and we randomize. Don't forget, it has to be randomized. And then if we can say, well, let's control how much computer time and how much blood pressure, then we can say there's causality because we controlled for one group while we treated the other. Actually, I did that backwards. We controlled for one group while we treated the other. This is a really good video. If you want to, you should watch it. But I think this was probably one of the best representations I've seen of the difference between the three. All right, so we're going to talk sampling and bias. Let me take a quick look at all my faces and see if everybody looks happy. Again, I only see the tops of your heads. What is that about? Thank you. All right, Reed, you're good. All right, you guys probably remember this. We talked about all the different sampling types there were. A simple random sample, or an SRS, is just when you take a whole population and you somehow randomly select a number from that population. And there's no rhyme or reason to it. It's like drawing names out of a hat. That's the best simple random sample example I can give you. If those are all mixed in really well and everybody has an equal chance of being picked, then that's a simple random sample. Convenience is when you say, well, let's take the one that's closest to us, this big chunk of people are standing right where I am. That's who I want to take. And that's convenient, but it's usually a biased sample. We don't like convenient samples. Systematic is when you say, line them up. I'm going to take every 4th one or every 7th one. That's systematic. Stratified is when you say, okay, I have 3 groups that have similar characteristics. And those 3 groups could be something like age or gender or grade level, like this could be seniors, juniors, and sophomores. And you say, depending on how many are in each group, I'm going to proportionally take a few from each of those strata. So let's say there's about 100 seniors and you want to take about 8 of those. And there's 100 juniors, and you want to take 8 of those. But there's less sophomores, so you'll take less of them. That's called quota sampling. You're trying to match the sample size to the amount or proportions that you have in your strata. And then a cluster is like you take one whole group from someplace and you test everybody in that group. Like we talked about baseball teams, you do all of the people on a baseball team for drug testing, and you pick maybe 2 or 3 teams for that day. So quota sampling is when you're trying to match. So for instance, let's say that 67% of shoppers are women and 33% are men. And I have no idea if that's true. I made it up. But 67 is about twice what 33 is. So if you were going to take a sample, you probably want to have twice as many women as men to account for the gender differences. It wouldn't be fair to give the men as many in the sample as the women because they're less apt to shop. Okay. I think we've done this before, but let's do the Ravenclaw, Slytherin, Hufflepuff, and Gryffindor thing. So let me unmute everybody if you guys will let me. Sometimes you don't let me and it's funny. Okay. So we're doing the Triwizard Tournament. If I say, let's separate the students by house and take 5 from each of the houses, Ravenclaw, Slytherin, Hufflepuff, and Gryffindor, what kind of sample is that, Jake the Snake?
Stratified?
Yes. All right, but what if I take 2 of the houses and I say, let's get everybody in each house? What kind of sample is that, Laura Rhodes? Laura, I didn't hear you. Did you type it? Let me see if you're typing.
I'm just thinking about it.
Oh, you're just thinking, okay.
Yeah.
I'm taking 2 entire houses and getting everybody in that house.
Is that systematic?
Everybody, the entire house. So I can't just skip 3 people and then take the 4th because then I would be skipping 3. Everybody in that house has to be done.
Cluster?
Cluster. Okay, so let's say I'm going to take the first 25 who enter the Great Hall for breakfast. Let's do Lauren.
Convenient.
Yes. Okay, so how about I pick a house and a year and then either witch or wizards, and I randomly pick 2 witches or 2 wizards from this group. What do you think that's going to be? Actually, that's not even on the last slide. This one, I don't think you guys. Anybody remember it? It's kind of a mixture of one and another. So what they're saying is they took a house, they took a cluster, and then they stratified within the cluster. So they're actually doing both of those things. What do we call that, do you think?
A stratified cluster.
Well, yes, let's go with that. Or you could say multi-stage. How about I list all of the witches and wizards alphabetically, and then I pick the 20th student, every 20th student in that list. What would you call that? Morgan. Morgan, your mic is on.
Is it systematic?
It truly is, yes. And then what if you put all the names in the sorting hat and you just pick 12 of them? Let me do either Brandy or Reed. You're going to have to type it in the chat room. Let's see who's first. Yes, Brandy. Excellent. SRS, simple random sample. Well done, you. All right. So look at this picture. Here we have blocks of people. You can see this block, this block, this block, this block. And I'm going to take this whole block and this whole block. What would you call that? Anybody? Nobody? You're taking.
Which one are we on?
We're taking this one with the people. These people, and they're blocking them out so that you have like this block. All of these people were pulled, and all of these people were pulled. I know it's kind of hard to tell, but what we're saying is the people in yellow are one group, and the people in blue are the other group. Actually, I'm not sure if that's right or not. Let me unveil it. Stratified. They're calling it stratified. So they took a piece from this group and a piece from this group. So some from each. Does that make sense? How about this one? Let's look at So you had 4 groups of people and you took all of group 1 and all of group 4. Yep, I see Laura says cluster. How about this one? It looks like you have section 1, section 2, section 3, section 4, and section 5 of a neighborhood. And you took 3 houses from this section and 4 houses from this section. I wonder what that's called. What does it appear to be? If I had to guess, I know what I would say. Yep, that's what I would have said. Well, they're saying clusters for some reason. Laura, I agree with you. I think it's stratified. I'm not sure how it's a cluster because all of section 5 is not chosen. I think this is stratified. Trying to figure out how they called it a cluster. It makes no sense. Unless because the color houses are all red. That could be it. Maybe because they chose all of the red houses in the neighborhood. Weird. This one looks like, if you had to guess, where they took 3 from this box, 2 from this box, 3 from this box. What would you say?
Is that also stratified?
Yeah, that one definitely looks stratified. I see how this is a cluster now because they took all of the red houses. How about this one? They took this whole box and this whole box. Yep, I say cluster too. And then this one, they took all of these together. From this population, they just got all of these together. But now there's no like grouping of anything. The whole population is just, it's random. So there's no particular sorting out, but they just took all of these that were in the same area. Yes, Brandy, convenience. That's what I thought. Okay. Moving along. Okay, so then we talked bias. We talked a voluntary response bias is when people have strong opinions, so they volunteer them. And they say anytime you have a poll on the internet, it's most likely voluntary bias because only the people who feel very strongly, like the Dear Abby letter where they said, would you do it again if you had to have kids? And most people said no. Undercoverage is when some part of the population is either not represented well or not represented at all. They were intentionally left out. So for instance, undercoverage would be if you do an internet poll for all of your constituents and half of your constituents are over 80 years old and none of them have the internet, then they would be undercovered. They wouldn't be counted in that. Non-response is when people have the ability to respond, but they choose not to. So robocalls are usually non-response bias because 90 to 95% of people don't return those calls. And response bias is when you have influential wording or undue intimidation. Like influential wording would be, do you support this even though it may cost several $1,000s more? They're kind of telling you, hey, this is a bad idea within the body of the question. Or you could say, if a police officer said to you, son, are you high? Then that would be response bias too, because how many people are going to say, why, yes, officer, I am. So let's play a matching game. So let's do this first one. An interviewer selects a random sample of individuals to question about a particular issue. Since some of those individuals are not informed about the issue, the interviewer gives background and his personal view on the issue before recording their responses. It is one of these 4 biases. Which one do you think it is?
Is it a response?
Yes, yes it is. Because they're leading the people. So a response bias is when they're telling you what they want you to respond. All right, let's do this one. A politician would like to know how her constituents feel about a particular issue. As a result, her office mails questionnaires about the issue to a random sample of adults in her political district. What do you think that one's going to be? Response bias? Wait, that was more voluntary? Maybe. Let's move on. I know there's one for each of these, and that one does look like it could be a couple. Let's move on. Let's go down here. A news show asks viewers to call a toll-free number to express their opinions about a recent high publicity trial. What would you say this one is? Yeah. Lauren, I agree with you. I think that's voluntary because when you're asking people to call in, only those with very strong opinions are going to want to call in. So they'll be swayed probably one way or another. Let's do this one. Company uses the telephone directory to randomly select adults for a telephone survey to gauge their feelings towards towards items manufactured by the company. What do we think on that? Either non-response or under coverage?
Probably under coverage since it's a telephone directory and not many people are going to pick it up.
Probably under coverage. So you think that there's people who are being left out? So yeah, I would have to agree because not everybody has phones. And so if not only the people who have their numbers listed in the telephone directory are going to be called. So everybody who has private numbers will not get a chance. So that is, I think you're right. I think it's under coverage. So let's go back. Did we say non-response for this one for the politician? I'm kind of in the chat room. I'm not sure which one was which. So when you mail out questionnaires, how many of you actually return those by mail? Has anybody ever gotten one in the mail and they returned it? No, nor have I, except the census. And I just want to put in a plug for the census. It is in the Constitution. It funnels money to our district. So if your parents have not done their census yet, please beg them to do so. It took me 5 minutes. So that is the only one I do religiously every 10 years. Other than that, I would not do a survey in the mail. So I think whoever said non-response here earlier, I think that one was probably correct.
Miss Yanarella, you said that as soon as my mom walked in and she
And
just kind of smiled.
has she done her census?
No.
Oh, please ask her on my behalf to do that. Okay, so oops, where am I? Oh good, I haven't revealed the. Which of these are non-response? Each person in a simple random sample of 2,000 received a survey and 317 people returned it. How would it cause the results of the survey to be biased? What's the problem with non-response? Anybody? Why do we have an issue with non-response? Everybody's muted again. You guys are hilarious. Okay, I'll just reveal it. The problem with non-response is the people who don't respond may very well sway the survey to something entirely different. So we really, if you're not getting enough people responding, you really can't say definitively you know how the population feels or even the sample feels. So that's the biggest issue with non-response. All right. Experimental design and observational studies. Okay, I went through the vocab and I just want to talk about them real quick. An observational study is where you pick data but you don't manipulate it. An experiment is where you do manipulate it. So you assign treatments and controls so that you can actually make some kind of causal analogy. A confounding variable and a lurking variable. I swear to you, every year I look these two up and every year I say, huh, that sounds like the same. But here's what I think the difference is. I think confounding is something that you can change that would sway the data, but lurking is something that is there no matter what. Both of them may somehow change what the answer would be, if you could somehow remove them. So confounding and lurking variables are variables that sway the data and that they have no true association, but they may be somehow linked to the data in a different way. Like, remember we talked about TVs in countries and lifespan, and we said, well, if we throw more TVs at a country, will that increase their lifespan? And we said no, because TVs represent wealth. And TVs in themselves are not really the reason people live longer in some countries. It's the wealth of the country. A treatment is when you do different things to your subjects in an experiment to see what will happen if you do something here and something here that are two different types of treatments. A level is how many different ways you can make a factor, and we'll talk about that in a minute. And a factor is the different variables that you're manipulating. Single blind is when the people who are being treated don't know what's going on. Double blind is when the people giving the treatment also don't know who is getting the treatment and who isn't. Matching is when you can match up pairs of people or things in an experiment so that the two have very similar characteristics and one gets treated and the other doesn't. And blocking is when you separate your groups out by certain characteristics that make those groups very similar. And one of the biggest ways we block is by gender. Any kind of drug trial will usually block by men versus women because our bodies are different. And so women's bodies will react differently to a drug than men's bodies. So blocking is almost always done by gender in drug trials. But remember when we did the dog blocking, we blocked by breed. We had the Beagles and we had the Dalmatians and the Collies. I'm not getting any head nods, but I hope you guys remember that. Read this when you get a chance. I'm still stuck on lurking versus confounding, but I know both of them are bad for variables. When you're trying to make some kind of sense out of your data, if you have a lurking variable or a confounding variable, it messes you up. Remember they talked about the ice cream sales and the drowning? They said, do ice cream sales affect drownings or do drownings affect ice cream sales? And we said, no, they both have the heat. The lurking variable is the heat, and they both occur more during hot weather than cold weather. And confounding is when something is introduced that could be changed. Like, for instance, if a store runs a special promotion and there's bad weather, people could say, well, the bad weather made the video sales go up because people were staying home more. But was it the bad weather or was it the store's promotion? So you can't separate them out to find out which one really caused it. Okay. So let's do the warm-up. Some people claim they can get relief from migraine headache pain by drinking a large glass of ice water. Researchers plan to enlist several people who suffer from migraines in a test. When a participant experiences a migraine, he or she will take a pill that may be standard pain reliever or a placebo. We talked about placebos. They're to keep people from realizing who's being treated and who isn't. It controls for that effect of that mental effect that says, oh, I should be getting better because I got the treatment. Half in each group will also drink ice water, the rest regular temperature water. Participants then report the level of pain that they experience. So the subjects studied are people with migraines. And the factors are the water and the pain reliever. Oh, I forgot there was a pain reliever. So they give a pain reliever and they give water. And the levels in each factor, so the pain reliever, let's see where the pain reliever was. It's either a pill or a placebo. So for the pain reliever, you either get a pill or a placebo. And for the water, you either get ice water or regular water. So the factors are pain relievers and water temperatures, and their levels, how many levels within that factor are this and this, and this and this. So when you do number of treatments, you usually multiply the levels together. So I have 2 levels of pain and 2 levels of water temperature, so I should get 4 treatments. And the response variable is their level of pain. So whatever we're measuring is how much pain do you feel after we've done one of these 4 treatments. And so the design would probably be a completely randomized, unless we have men and women, and then we may want to block by that. Is it blind? Well, yeah, the people getting the placebo can't know that they're getting it. So it's definitely single blind, and it could possibly be double blind. And then the nature and scope of the conclusion. The experiment may indicate whether ice water in addition to pain can help. Oops, gosh, what am I doing here? Undo that. There we go, move this. Ice water in combination with pain relievers may give relief. So that's kind of just your whole experimental design, going through all the different vocab words we talked about. I put all these notes in here and I'm not going to cover them, but these were the chapter 13 notes, and it's well worth you looking back on them so that you know. Here's a big one about experimental design. They call it the 3 big principles: control, randomize, and replicate. There is a 4th optional, and that is block. Block is optional, so we don't call it one of the main principles, but if you had something like dog breeds or males and females, you would want to block as well as control, randomize, and replicate. Control means you treat one group and you hold the other group the same so that you can measure the differences between the groups. Randomize means you don't favor one group or another, so you randomly assign. So if you had 100 participants, you would draw names out of a hat, maybe for the first 50 who are treated and then the next 50 who aren't. And replicate means you have to do it over and over, so you don't have just like a one fluke thing where, oh, hey, that one experiment showed us this, but all the other 99 showed us something different. And there's your confounding and your lurking. Boy, I wish I could get those 2 straight. Okay, so let's do this one real quick. So a chemical engineer is designing a process for a new product. The reaction that produces the product may have a higher or lower yield depending on 2 things: the temperature and the stirring rate. Those are each your factors in the vessel in which that reaction takes place. So what that engineer is going to do is he's going to make 2 different temperature levels, 50 Celsius and 60 Celsius, and 3 stirring rates, 60 rounds per minute, 90 revolutions per minute, and 120 revolutions per minute on the yield of the process. 10 batches of feedstock are produced at each combination of temperature. So what are the experimental units? What is it we're actually putting in to our experiment? Anybody want to take a crack at 6? Everybody's saying A? Is everybody saying A, or is this from an old
That was the other one.
Oh, okay, I was going to say, yeah, that doesn't make sense to me. Nobody wants to weigh in on this? All right, I'm going to go ahead and uncover it. I believe it's the experimental units are, well, let's see, the batches of feedstock. So you put a batch in and you experiment on it based on its temperature and its stir rate. And then all of the factors are the temperatures and the stirring rates. They're both factors. And then what are the response variables? Well, we want to know, let's see, what is the response variable for 8? It's the yield. How much does it yield in the batch? So it's none of those, it's the yield. And number 9, how many treatments are there? Well, you take your levels, 2 temperature levels and 3 stirring rates. So there'll be 6 different treatments because you have to mix and match each of the temperature rates with this, each of the temperature levels with the stirring rates. How many experimental units are needed if you need 10 batches for each treatment? Well, there's a treatment there: temperature of 50, stir rate of 60, temperature of 50, stir rate of 90, temperature of 50, stir rate of 120. And then you have to do the same for the 60 temperature. So there's going to be 6 different treatments, and you have to put 10 batches in each. So you actually need 60. You need 60 batches. And then I love this one. I think I did this before with you guys, but I can't remember it. But they talk about 420 college students and they want to do a blind taste test for food service. So what they're going to do is see how they can improve their lattes. So they want 2 types of coffee beans, the Arabica and the Robusta. So I said, here's your 420 college students: Arabica, Robusta. Each group gets 1 bean or the other. And then 3 types of syrup: vanilla hazelnut, vanilla hazelnut, and mocha. And then you have to do 1 for each, the Arabica and the Robustas. And then you have 2 different milks, soy and low fat. So you can see this is a factor, the type of beans, and there's 2 of them. This is a factor, the type of syrup, and there's 3 of them. And this is a factor, the type of milk, and there's 2 of them. So it ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 treatments. So you would divide those 420 kids up into 12 different treatments, and hopefully there'd be a balanced group in each one of these treatments. And then you would somehow measure their taste combination. So what do you think confounding variables would be in an experiment like this? What might confound your data? Don't everybody shout at once.
Would it be like people's like taste buds or whatever?
Absolutely. Like, I don't know if you remember the Adrian Hill video, but some people hate coffee. So if you take 420 college kids and you put most of the haters in the Arabica, that's definitely confounding. That's a great one, Lauren. What else might be a confounding variable? So let me propose this. There's not one person who's going to make 420 college beverages, right? So what if there are 3 different baristas, right? So wouldn't the barista themselves maybe be a confounding level? Like, sure, they may do the Arabica and the vanilla and soy, but what if they grind the Arabica beans like more finely than the next person grinds their beans? Like, there's coarse and there's fine, and it does lend a different taste. So the actual makers of the coffee could be a confounding variable. So if, you know, the guy who grinds his to a real fine powder does all the Arabicas, and then the girl who doesn't grind hers to a powder does the Robustos, that might also affect it. How can I block this experiment? How would you block a coffee taste experiment? Who loves coffee? Jake, no?
No.
Somebody raise their hand. Was that Reed? Reed, okay, so if that was you saying you love coffee, nod your head yes or no so I can see. Is that you who loves coffee or not? I adore coffee. So here's how I would block it. You and I would have to be in the same treatment, because if we both love coffee, we're both going to rate it very highly, almost no matter what we get. But for Jake and say Brandy, who don't like coffee, they should be blocked in the non-coffee drinkers. So that's the way I would do it. I would block by how strongly you enjoy the beverage. So if somebody said, rate how much you like coffee on a scale of 1 to 5, I would put all the 1s together, all the 2s together, all the 3s together, because then that would make more sense to get that kind of a level of appreciation for the coffee. All right, guys, we're getting there. I only have 10 more slides to do. I highly recommend this YouTube video. It talks about all the different designs, and it goes through how you would do it. So let's say you had a completely randomized design. You would just take all of your units, divide them into 2 groups randomly, not intentionally, but randomly, like draw your name out of a hat for group 1, and whatever is left over is group 2. N means how many groups you want. So it could be 3, 4, 5 groups. And then randomly assign the treatments to each group. And then you compare your results. For a block design, you may say, well, let's block by gender or dog breed or age or coffee loving. And so all the dogs of this breed get this random assignment treated 1 and 2, and all the dogs of this breed get this randomly assigned treatment 1 and 2. For a matched pairs, you're going to say, so let's compare. To me, the best matched pairs design I've ever heard is when you do one person wears a boot on one foot that's treated one way and a boot on another foot, because that person's walking all the same steps all day. So that's a great matched pairs. Or twins are a great matched pair, because twins are the exact same age. They're usually the same height, the same everything. So their bodies are very close. So whenever you do, say, a drug trial, you'll do a matched pairs with twins. So I highly recommend this video, and I don't want to try and over talk about it, because this guy did a great job. I think it's 6 minutes, so I would watch it if I were you. I'm going to post these notes. And then here's a block design by females and males. Let me see if I can make that smaller so you can see it. And then here is a matched pairs design using the same car, goes somewhere on type A gas and the same place on type B gas, so that that car, whatever it is, has 2 different, and maybe you'll compare its fuel efficiency. So let's say you put type A gas, which is ethanol treated, in car 1, a whole tank, and you drive it for 400 miles. And then when it's empty, you go and put type B gas and drive that same exact car for 400 miles. So that's considered a matched pairs design. And matched pairs is a kind of a form of blocking. And then this is one for people who are sleep deprived. If you were the same level of sleep deprived, one person would do one thing and the other person would do the control. and then you compare, and then you have another level of sleep deprivation and a third level. So you can see you're matching people who have the same characteristics, and setting one is the control, the normal, and the other gets the treatment. And remember, we did the dogs, and we said that when you did a completely randomized, it was hard to find out bone density because each of the breeds had such different bone densities themselves. So when we did it by breed, we got a much better reading. And remember, you only compare within the blocks. You don't compare these 3 treatments to these 3, to these 3, to these 3. You only compare within the block. And it made no sense to do it by clinic because clinic had nothing to do with breed density. So we said this was a bad design. Hawthorne effect is when people alter their behavior because they know they're being studied. So there's that famous story about the changing the light bulbs at the factory and how productivity went up as they increased the lighting. And then even when they started decreasing the lighting, productivity still went up because they realized somebody's watching us. So that was the Hawthorne effect, which I thought was cool. All right, you have 28 problems in College Board, and you have some Khan Academy activities. The Khan Academy activities were really fun. I was doing those. Let me see if I can show you what they look like. Let's see if I can try not to look at everybody's scores. Let's see. So yeah, this is bias in samples and surveys. So you're going to answer these questions, and you're going to match the biases, and you can do it. I think you can do it as many times as you want. I don't think it's limited to one time. So let's see if I can go back to your Google Classroom. You're going to have, here's the YouTube videos. I think this one, yeah, both of these are the Khan Academies. And then I had to add a third Khan Academy. So it's up here in a separate link. So this one is sampling methods. So you actually have 2 Khan Academy links to do and 1 College Board. You have to go and do the College Board stuff as well. So I think there's 28 questions in the College Board. So remember, the College Board looks like this. So I should see all 14 of you should complete those. And I'm not necessarily, if you don't get everything right, I'm cool with that. I just want you to go through the motions because College Board probably has the closest to what types of questions you'll see. So please do go through the motions and actually look at every question and try and think about it. Is anybody seeing the answers after you click on it, or do they not post answers? It's possible I can change it so they do show the answers, so I might do that if you haven't seen them yet. All right, guys, I'm done. Anybody have anything? Okay.